Welcome to another episode of Let's Code on IBM Expert TV. I'm pleased to have with us today Jamie Coleman, a developer advocate covering Open Liberty, Jakarta EE, and MicroProfile. And today, Jamie will be taking us through the first episode of a three-part series on Open Cloud Native Java with Open Liberty and OpenShift, but featuring different clouds. This week, Jamie will be covering IBM Cloud and developing an application for with those capabilities on IBM Cloud. And then in 2 weeks, we'll cover Azure. And then on November 18th, we'll finish the series with AWS. Jamie, welcome to the show, and please take it away.
Brilliant. Thank you, Neil. So hello, everybody. Good morning, good afternoon, or good evening, depending where you are. My name is Jamie Coleman. I'm a developer advocate for IBM. And today I'm going to take you through building a simple application, a microservice using Jakarta EE, using MicroProfile, and then we're basically going to package that up in a container and deploy that to the IBM Kubernetes service. So like Neil said, we are going to be going through different technologies. So next week, we'll be looking at a different cloud, and then eventually we'll wrap it all up by deploying OpenShift and deploying it to that. So let me get started. I'm just going to give you a brief introduction to some of the technologies we're going to be using today. So again, we're going to be using the IBM Kubernetes service and the IBM container registry to basically store our images. And then we're going to be using technologies, open source technologies locally to build our application. So the stack we're using today is fully open source. So we're going to be building our applications with MicroProfile and Jakarta EE APIs. The runtime we're going to use today is Open Liberty, and we're going to be building these on top of OpenJ9. So Eclipse MicroProfile, bit of a quick intro. It's an open source community specification for enterprise Java microservices, and essentially a community of different individuals and organizations all kind of came together to create this project to bring microservices to the enterprise Java community. These are the different contributors, so thank you to all of them, because MicroProfile wouldn't be where it is today without them. And the great thing about MicroProfile is it's vendor neutral, so you can go to any one of these different vendors for support, which is awesome. So this is the MicroProfile 4.1 stack. These are the different specifications available in MicroProfile 4.1. There are other standalone projects you can use as well. So things like reactive stream operators or MicroProfile reactive messaging work amazingly well with the rest of the MicroProfile stack, and they're designed to do so. So again, the runtime we're using today essentially is Open Liberty. So Open Liberty kind of is an open source project by IBM. It was open source, the source code with OpenJ9 about 4 or 5 years ago now. And essentially, the Open Liberty's kind of goals is to focus on code, focus on you as a developer. We want you as a developer to be able to make quick changes to your applications. Testing, we want to make that easy using things like test containers to create true to production testing. Open Liberty and Webs for Liberty were one of the first IBM products to be containerized. And again, we wanted to offer tools and flexibility, so to give you, the user and the developer, the choice to use whatever you want rather than being forced to use certain things. So developer mode is quite a cool thing in Open Liberty. We're going to be using it today. It essentially allows you to start the runtime and make changes to your code, your application code, your test code, and even add features and functionality and configuration changes to the runtime without having to restart it. So again, wanted to give developers flexibility. So it's available, there's tools available on lots of the main IDEs. You can get stuff from Maven Central, Docker Hub. There's loads of different build tools, Maven, Gradle, or even Ant if you want to use that. We support the main APIs, MicroProfile, Java, Jakarta EE, and Spring. And of course, testing. So with containers at its heart, got microshed testing and test containers. And there's also you can use JUnit, of course, in Aquilium. So a pinnacle thing of Open Liberty, essentially we really want to create an application server that you write code for once, and you don't have to keep making changes to your code to use the latest version. Of course, there's 300 odd developers working on this project, and to have people on old versions isn't great because you're not going to get the new functionality. So you can create, for example, a MicroProfile Jakarta EE application on an older version of OpenLiberty and download the latest version of OpenLiberty and move your application to that without it breaking. So OpenJ9 is awesome JVM for cloud developments. So JVMs, the things with JVMs is they have lots of different characteristics, and if you basically change those characteristics, they can have detrimental effects on other ones. So picking the right characteristics for a cloud deployment is difficult, and I think they've got the right balance here. And that means getting a faster startup time. You don't want to have to sit there and wait for your applications to take ages to scale up and down. Smaller footprints, again, once you've got it running, the JVM essentially is an overhead with Java microservices. So you want to get that footprint as small as possible. Ramp up time, again, the time your application takes to start up, it's pretty much wasted resources until it's at its max throughput or it's perfect throughput and it's trying to get those requests, it's pretty much wasted usage. And again, a smaller footprint during loads, where you don't want your JVM to be performing badly or consuming loads of resources under load. So OpenJ9 is quite good for that as well. So just a quick comparison with, say, OpenLiberty. This is using OpenJ9 with shared class cache enabled. And as you can see, it will start up in around 1 second with a MicroProfile Jakarta EE application, which is pretty cool. So what we're going to be building today, so enough about the tech. But today we're going to be building a system microservice. So we're going to be actually creating the system microservice. And what this does is it returns the system property information for a specific host. I'm going to provide the code for the inventory microservice for you in the essence of time. But essentially that just tracks the number of systems you have. So if we deploy the system service to, for example, lots of different machines, if you invoke the inventory service, it would record each of those and it basically saves them to a list and then retrieves them when you hit the endpoint. So for the first part of our application, we're going to be using Jakarta EE's JAX-RS and Jakarta EE's JSON-B. So a bit of information about these. So JAX-RS, it's a MicroProfile and Jakarta EE technology. The thing, JAX-RS is great because essentially it allows you to define endpoints. So you can use the @path variable here. So this is a coffee shop application that's in this slide. Essentially, we're producing JSON, and that's generally the format we use for microservices to communicate with one another. And we're consuming JSON. And essentially here, we're just starting the brew of a coffee. So nice and simple. JSON-B and JSON-P are quite cool. So we're going to be using JSON-B in this service we're going to be creating. Essentially, JSON-B allows you to turn basically turn a Java data bean or Java data object into JSON without any, and basically send that to a different microservice. That microservice will then consume that JSON and turn that straight back into an object. So you as a developer or the user don't have to worry about getting Java objects and turn them into JSON. JSON-B will handle all that for us. So yeah, takes that away from what we need to do. So the inventory microservice has quite a few different more specs. As you can see, it's got the Jakarta EE JAX-RS and the JSON-P we were using before and JSON-B, but it's also got CDI, so context dependency injection, also using the MicroProfile REST client and MicroProfile config with the MicroProfile health check. So the great thing here is really to show that with MicroProfile and Jakarta EE, you can combine them together to make some really, really good microservices and cloud native applications. So it's great having these microservices, but now we need to deploy them somewhere. Generally, containers are great, but now we need a better way to manage them. So as the first step in this series, we're going to be using just a general plain Kubernetes service to get started with. And then we'll move on to some more advanced things like using OpenShift. Now, Kubernetes is great because it provides different things like horizontal scaling, self-healing, automatic rollouts and rollbacks. You can handle secret creation and configuration management, service discovery and load balancing, and then also intelligent scheduling. Now, OpenShift essentially takes this another step further and gives you even more control over essentially your containers underneath. Okay, so let's get started now. We're going to start to do some coding now. I'm just going to move StreamYard over here. Okay. So we'll just open up a terminal. I'm using the Ming one, but so this would essentially be mimicking what a Linux terminal is. There are two. Let me just close this. There are two repos of interest today. So we're going to be using this one to just essentially get started. This is going to provide us with some basic bare bones code and the files we need and the structure we need. And then once we've built our system service, we're then going to move to this repository, which has the inventory service created. And I'll take you through what's inside the inventory service once we build the system service. So first things first, we need to clone down our repo. So just get that. Clone. So one thing I'm going to do before we start this. So first of all, we do need a Kubernetes cluster. Now I've got one running already, but it's very, very simple to create one. I'm using the free tier, so I'm not paying for any of this, and it's the same with anyone else. So if you're on the IBM Cloud dashboard, just go here and then go to Kubernetes, this little box here. And this will basically show you your running clusters. Now, of course, I've already got a cluster, so it won't let me create a second free cluster. But if you want to create one, simply just go here. Obviously, you can use the standard one, which will give you different options. So you can run it in multiple locations, have it multi-zone, and you can also select how many kind of worker nodes and the resources you need. But again, for this demo, I'm just using the free one. It won't let me create one, like I said, because I've already got one. But the only option here, really, it'll give you, you just need to give it a cluster name and then click create. It takes about 20 to 30 minutes to create, so it's not too bad. And by the time we've created the system microservice and tested that and put that into a container, it'll probably be done. Just to call it safe, I've got one created already. So yeah, this is our essentially our Kubernetes cluster. You've also got your container registry here, and this is essentially where we're going to store our images before we deploy them. Ooh, put that back up here. And in here, you can see things like your namespaces, the images you've got already. So we've got one here. I've got one here. I'm just going to delete that. So we've got a nice clean space. All right. Okay. So let's get going. So we've got our repo. So we've got the guide rest intro. So we're going to navigate into that directory. And then we're going to navigate into the start directory. So what I'm going to do is just open up my IDE from in here. So I'm going to use VS Code for this demo. Just give this a moment to start up. Okay. So while I'm doing this, what I'm going to do is I'm going to run Liberty in dev mode. So like I said, Liberty dev mode essentially allows us to run our application server and make changes on the fly without having to keep restarting or worrying about the runtime, essentially. So it makes our lives easier as developers. So simple thing, all you do is maven liberty dev and then dev mode should start. So while that's starting up Liberty, it might have to download a few things. So it downloads any kind of dependencies it needs from Maven. I'll have to download the runtime, obviously. But while that's doing that, we can go ahead and we can start creating our service. So we've got a basic POM here. So the POM, basically it lists our dependencies that we've got, a few variables here, which I'll talk about later. Got some dependencies for testing, and that's pretty much it. So, and then some configuration for Liberty at the bottom. So what I'm going to do, I'm going to get started. Let's go into the system application. So the system application essentially is a way to again, we're going to be building an application that's going to return the system properties of the host that it's on. So what we're going to quickly add here is essentially a wrapper that's going to go around our application. So this class will extend the application class, and this will associate all kind of JAX-RS resource classes in the WAR file under a common path. So I'm just going to quickly copy in the imports we need. So we need the application import and the application path import. So then all I need to do is annotate the class. So application path, give it a name, so system. So this will essentially group all our kind of endpoints under this common path, just to make it life a bit easier. And the only other thing we need to do now is extend the application class. Okay, so extends. All right, so now we've done that, nice and simple. Now let's just go back here. So our application server started, and it started in dev mode. So if I save this, we should notice, just close that. Okay, so we should notice our application being updated. Again, takes that away, extracts that level of worry away from us, so we don't have to worry about it. So now we've got this, which essentially will group our resources under one common place. We need to actually create the resources or the API endpoints that we're going to be calling. So we're going to call it properties resource.java. Okay, so we've got our properties resource. Then basically we just need to add in, I'm going to add in the imports quickly, just to save a bit of time. So we're importing the Java util, the properties class, basically to get the properties of our host. We've got the get here, so we use that to make that annotation to basically say it's a get method. Path variable, so this is to basically give the URL path we're going to use to get access this endpoint. At producers is basically the media type we're going to produce, and yeah, and then the media type is going to be JSON. So let's quickly type that in. So first of all, we need the @path variable on the class above the class name. So let me just do that. So we're going to call this properties. Okay, so that's all we need there. And then basically we need to create a method in here. It's going to be a get request. We're going to put the @produces, and then we're going to have the media type of. So there are different ones. So you can use XML, or you could just do plain text. But we're going to use JSON as in a string for this one. So yeah, that's all we need. So it's going to return JSON. Then we need to basically create the method. So public it's going to turn properties. So this is where JSONB comes in, because essentially this will then turn the properties it will turn the properties that we're going to return into JSON essentially. And if we had another microservice, that would basically be able to consume that and turn that back into an object again. So let's just create this method. So it's going to be a really, really simple method. All we're going to do is return system.getProperties. Okay, and that's it. So we basically created a very simple microservice here. So we've got two classes. This one basically groups all the resources in the war under this common class path. And then also the same, basically here we're defining that this class here will be called by using this path. And then if it's a get method, get request, it will return this JSON, and the JSON will be the system properties. So our application server should have updated. Yep, which is good. So now we just need to basically configure the server. So this is quite easy in OpenLiberty. Here we've got the servlet 4.0 feature. We don't need that because we're not running a servlet. So basically what we want to do is add the JAX RS feature. So JAX RS 2.1, I think, is the latest. Okay, so I've added that in. The only other thing I'm going to add in is I'm going to copy it in a little bit of configuration code here. So if I basically, the changes here I've made are I've added in the HTTP port, which is an environment variable. The HTTPS port, the same thing. Host star just means anyone can access this runtime. And the context root is essentially the application name. So I can save these, and again, this will then go install the required features, so I don't have to worry about starting the runtime. Now, you're probably thinking, where are these coming from? They are coming from the POM file. So if you remember at the top of the POM file, we basically had this Liberty configuration. And here we're setting the HTTP port, the HTTPS port, and the context root. And that will now essentially allow us to utilize the same config in our server XML. Because when we've got loads and loads of microservices, we don't want to have to go into the actual configuration and do it. You might want to do it from a higher level, for example, in the POM XML when you do the build. So basically, it just takes a few layers away and abstracts them away. Okay, so while that's doing that, that will be installing that. Now we should be able to hit the application. So let's have a look. So we need localhost. Yep, so system properties. So let me just make sure the application is updated. Yep, that's all good. So now if I hit this, this should turn, yes, this is JSON, and this is basically the JVM properties of the host we're running on. And that's my local machine at the moment. So that's very simple. There's only one more thing I want to show you in regards to testing this service. So if we go back to our IDE, there's a test directory here, which is pre-created. So I'm going to create a file in here called endpoint it and base.java. And essentially, I'm just going to copy in some test code and quickly explain what it does. So essentially what we're doing here, we've got our JSON builder, and basically the at test annotation said this is a test. And as you can see, we're building the URL here. And we're doing this by getting the system properties. So again, like I mentioned that we did with the POM XML, we're taking these properties and using them in our test code. Now, this is not so important now. Of course, it's better to not hard code these kind of things, but this is important for when we actually deploy to Kubernetes. Now, this will change slightly because you'll have to worry about your cluster IP. So essentially, we'd be replacing this with the IP of your cluster or wherever your application is running on Kubernetes. But it is quite important to inject configuration where possible. So we're building the client builder here. We're essentially just building a web target, which is the URL we're going to be, the API we're going to be hitting against. And then essentially we're hitting it and we're getting a response object back, and then checking that that response object has the right status code. And if it does, our test pass. And if it doesn't, our test fail. So I should be able to save that. Again, it knows I don't have to restart the server, etc. But now if I go and hit enter, it should go and run my test for me, which fingers crossed, they will pass. Ta-da, and we're all done. So we've basically just gone through using some Jakarta EE specifications that are also included in MicroProfile to build a very basic service. Now we're going to go one step further. So essentially imagined our team is responsible for building this service. Now another team has just built a different service which is going to utilize ours. So we're going to, first of all, close down OpenLiberty that's running in dev mode. And now I want you to go back a couple of directories, and we're going to clone down. I'm just going to close this IDE while we're here, this second repo. So there isn't much difference. It's basically got the same application that we created before, but with a few additions. Okay, and I'll just take you through what they are now. So once it's downloaded, let's navigate into the repo, into the start directory. So there's two directories in both these repositories, a start and a finish. The finish is kind of the finish, what we're trying to build essentially, and the start directory is just some bare bones stuff to get started. So let me just start at VS Code. I'll take you a little bit through the inventory application here. Okay, so again, the same. We have our system application. It's pretty much exactly the same application. So if I open it up, again, we wrap it all in here in our system resource, and we're getting the properties. Now, a bit different here, we're actually returning a response rather than just the properties. And the difference is here, we've got some extra things. So in the response header, we're basically going to get the pod name of the pod that's going to be running it on Kubernetes, and also the host name, well, which is the pod name. And yeah, so the application's the same. There's a little bit difference in configuration. So we have a parent POM essentially. All that does is really invoke the two child POMs, which are located in each of these directories. So there's one here. And this should be very similar to what we had before. The only difference you'll notice here is, like I said, we will have to use the cluster. We will have to change the cluster IP because this won't be running on a local host when we're actually running in the cloud. The only other thing really is the Docker files. These are very basic. So all of this, you don't have to have this. This is just yeah, this is just a good way to do your Docker images, is to label them. But really all you need essentially is that. So I've got a Docker image we're going to be pulling from. So we're going to be pulling the latest OpenLiberty image. We're essentially going to copy in our configuration and just make sure we have the correct permissions on that directory. And then we're going to do the same with our application and just make sure we have the right permissions in that directory. Now the run configure.sh, which I'm going to leave in, essentially what that does is it goes and runs a load of update scripts to make sure when we deploy that we don't have any vulnerabilities in our installed services and systems that are inside the container. So things like curl or whatever's inside this container, we just want to make sure we do apt-stack get update or something just to make sure they're all the latest version. Okay, so that's basically the system. Now, what the inventory service does is, again, it basically just kind of creates a list of when a new system or host is invoked and stores it to that list. So you can add stuff to the list, you can view the list, or you can reset the list. So I'll just quickly take you through that. It's very simple code. So like we had before, I've got this application, this inventory application, which essentially groups all the resources underneath under this common path, which is inventory. We have inventory manager. So this is essentially just a class that handles some of the logic, so adding stuff, resetting the list, etc. And then the inventory resource. So this is kind of the API we hit. So like we had with the system microservice, we've got the same thing here. The only difference here you can see is we are doing CDI. So we've got essentially request scopes allows us to make sure these things are all created for each request. If you had application scope, then it would stay up for the lifetime of the application. And then we're just injecting things like the inventory manager and the system client. What else? That's pretty much it again. So we just got a normal get here. This is the path. So the path to get a specific host name. We can get that. Of course, then we've got produces, which will just list all the contents or to list our different hosts, and then a reset thing, just a reset endpoint, just to basically reset the list if we want to. And the client and the model are just some things to do with logic and storing the data and interfaces, etc. Okay, so and this one's basically some of the logic for that. Also, we are injecting some configuration properties here, so you can see like the default HTTP port. So an example of using MicroProfile config to directly inject some configuration. Okay, so that's a bit of the overview of the applications we've got. And again, the reason I didn't go through building the inventory one is in the essence of time. So let's go back to our terminal. So first thing we need to do is we need to log into the IBM Cloud. So cloud login. I'm using SSO because I'm using my IBM ID. Let me just paste that in. Okay, so you log in. Essentially, you need to create your cluster. So like I said, you can either do it here by the IDE or you can do it via the terminal. It's easier generally just to do it by the IDE. Okay, so the cluster name here is the Open Liberty Demo Cluster. That's what I've called it, so nice and simple. Oh, I do have two accounts, so I just need to make sure I'm in the right one. So I've created my cluster already, so I'm not going to go through doing that. So let me just check that I can access my cluster. So you can do that by just typing IBM Cloud KS clusters. This should return all the clusters that are associated with your account on the IBM Cloud. So just give it a moment. And then what we need to do is essentially connect to that cluster. So to connect our local kubectl command line interface to the remote cluster. So that's done by going IBM Cloud, KS cluster, and then we need config, and then essentially we need to give it the cluster name. So cluster, what do we call it? Open Liberty Demo Cluster. I might already be connected to this from earlier. If so, it'll probably fail, but we'll find out. So just give that a moment. So it's just setting up any security it needs to, and then tunneling into the IBM Cloud. Once that's done, just to confirm we're connected to the cluster, all we need to do is do kubectl get nodes, and that should show us all the nodes on our cluster. So I've got a feeling, because I connected to this earlier, it probably won't let me connect to it again. So let's just check get nodes. So if this returns my nodes now, essentially we know, that's the problem. So I'm already connected. So if you do kubectl get nodes and it doesn't return any nodes, it just means your cluster might not be up. So like you see here, this actually said that my cluster was up. So you should be looking for this normal state. So at first it goes deploying, then it says something else. Usually, again, it takes about 20 minutes to set up a Kubernetes cluster. So not too long. Okay, so let's get started now. So now we basically want to package our applications. So maven package. This will compile them all for us and put them in a WAR file. And then the next thing we want to do is pull down the latest OpenLiberty Docker image. I'm sure I probably have it already, but I'll show you quickly how that's done. Nice and simple. Docker pull. Let me just get the image name because it's quite a long one. Okay, so this will pull down the latest version of the OpenLiberty image. Yep, like I said, I've already got it locally. So now what we need to do is we need to actually build applications and put them into Docker images. So that's easily done. Docker build -t. So let's first build the system 1.0 dash snapshot. And then basically we need to tell it to go and use the Docker file in the system directory. So that's what that last bit of the command is. So a lot of this was already existing, so as you can see, it built quite quickly. The main thing it's going to spend time doing is running that configure.sh. And like I said, we kind of keep that there. It's just to allow, when you're building the images, to essentially make sure they're the most up to date, because build time isn't as important as startup time. So once basically we're deploying this to the cloud, it will have already done this run.configure.sh command. So our images should hopefully be nice and up to date and vulnerability free. So give this a second, and then we'll build our inventory image. Okay, so let's go build our inventory image now. Cool. Again, it's going to run configure.sh just to make sure it's all there. So do make sure you've got Docker started locally, because obviously this won't work if you don't. I already started it up before this. Most people, if you've got Docker Desktop installed, I presume you probably have it start on boot. So when this is done, what we're going to do is then just check our Docker images exist. We then need to tag them, or essentially we then need to basically tag them with the right name so we can push them to the IBM container registry. So first things first, you will need to create a namespace. So if we go back here, you can go to the container registry, which is here. And I have already got a namespace created. It's called expert demo. This namespace essentially allows you to group all your resources under one place. And in this case, I've called it expert demo. So I will quickly show you the commands. You can either do that from, again, the GUI, or you can do it from the terminal. So hopefully this is done. Yep. So if you wanted to create a new namespace from the terminal, it's IBM Cloud CR namespace dash add space, and then whatever you wanted to call it. But I've already got one, so I'm just going to type namespaces, which should hopefully find the namespace I've already got created. Okay, cool. Yep, expert demo. Okay. So now we need to log into the IBM container service. So nice and easy, IBM Cloud CR login. It should use your saved credentials, so you shouldn't have to worry about typing in. Do note that I am running this demo in the UK. So I'm using the IBM UK's container service. So this may differ depending on where you're deploying this to. I think by default, it will pick your local geographic location, but do check where you're creating these things. Okay. So let's have a look to make sure we have the images at microservices that we packaged up earlier. Yep, so we've got this one about a minute ago and about 2 minutes ago. So that looks about right. They look like they're what we're looking for. So now we need to tag them or change the image name. So we do that by doing docker tag, not tog. So we put the image name here, 1.0-snapshot. And we want to basically call that, so it's going to be uk.icr.io, so like you saw here. And then we need to follow that up with our namespace, which was it expert demo? Expert demo, yeah. Expert-demo. And then we need to put the image name afterwards, so system. So system 1.0 snapshot. Okay, so that's the first part. That's all we need. So I'll tag the first one. And then we need to do the same for the inventory microservice. Inventory. Again, if you do get the UK bit wrong, so if you're deploying to the US, it will just say they can't find that host when you try and push these up. So yeah, just be warned about that. Okay, so we've created both of our images. So if I go Docker images, we should see them there now. Yep, cool. There they are, ready to go. So now we need to push them up to the IBM container registry so they can be accessed to deploy. Because of course we're using a remote Kubernetes service, so one running on the IBM cloud, it has to have somewhere that's accessible in the internet to pull the images down for your deployments. And that's, in this case, the IBM container service. So I'm just going to push up the inventory one first. So the layers already exist. So really all it's updating now is any updates that were made when the configure.sh script was run, or updates in the actual application itself. So that's the inventory done. So let me just get the system pushed up. Okay, all done. Okay, so now we've basically built a microservice ourselves. Another team has contributed another microservice. We've taken those microservices and the microservice works locally, but now we want to test them working in a real kind of cloud environment. So we've got those microservices, we've compiled them, we've packaged them up into a WAR. We've used Docker to essentially basically build some images from the configuration and the application code, and now we've took those, we've renamed them, and we've pushed them up to an online registry, which is in this case the IBM container registry. So now we need to go about deploying them to Kubernetes. So for this, we're going to use Helm today. So Helm is essentially a package manager for Kubernetes. It's very, very well known and very well used. So basically, first things we need to do with Helm is we need to add in the IBM charts repo. So IBM charts. And then we need to give it the URL for that. Just grab that. This will then basically add this repository or this repo to Helm so it knows it can use them in future. So what we need to do now is we need to go and deploy our microservices. So first things first, it's quite a big command. So I'm going to copy it into the IDE and then we can dissect it and fix it. So we're going to be putting the system app in, so that's all good. So it wants the repository we're going to use, so be careful here. I've got US, let's turn that to UK, and it was expert demo. So that's the tag, so that's all good. Pull secret, always pull it. The service, it's going to be, the Kubernetes service is going to be called system service. That's going to be the service port, the target port. We don't want SSL enabled because we're just doing a demo. And this is the chart we want to use, the IBM OpenLiberty chart from this repo. So let's take that and put that into our command line. Just make sure everything's all good there. Yep. Oh. Try again. Okay. So that should now go and deploy my system application. Awesome. So it says it's deployed. Hopefully it is. We'll find out soon. So let's just change this to the inventory one. So inventory. So change the repository and then just change the Kubernetes service name. All right. So I think we're ready to go. Oh, wrong button. So again, just copy that into the terminal. So the great thing about Helm is basically it can manage your deployments for you. So let's check if they've worked. kubectl get pods. Again, I'm connected to my remote cluster. So one's come up, as you can see, and its status is ready. And after 12 seconds, the second one is come up and the status is ready. So they will show the status as running because the application, the runtimes are running, but it'll take a few seconds, usually about 8 to 10 seconds for the readiness probe to probe it, just to make sure it can receive requests back. Okay, so we've got our pods, we're all good there. Our application is deployed. Now we actually need to do something with our application. So maybe look at it just to make sure it's actually doing something. So we do that by basically, we want to figure out where it's running. because we're using the IBM free tier, essentially we've got one worker node, so we need to go find what the IP address is for that. I've forgotten what Open Liberty demo cluster, I think it was called. We'll soon find out. So this will essentially will get us the IP address of our running cluster, so allow us to access our application. We've already set up a node port and things like that. So yeah, really we just need the IP address first. So that can be found. These are all the worker nodes for our cluster, and as we've only got one, we know our application is going to be running there. So this is the IP address for that. So nice and simple. So I do have a command here. So essentially what this will do, bear with me. So this will essentially go to the system service and basically pick out, because it's going to do a massive dump of information, but it will go and pick out the node port for us so we know the port number to access our system service. And then again, we're going to do the same thing for the inventory service. And all right, so everything should be all running now. This should all be running on the cloud. We've built our application. We've tested it. We've packaged it up. We've included another application from another team. We've built both of those. We've put them in images. We've put them in the IBM container registry. And now, hopefully, we've deployed them to the cloud. So first of all, let's go get the public IP address, which is this one. Let's go here. So that's our IP address. First of all, let's get the system service. So this is the one we created earlier. So that's our IP address, and I think it was system-properties. Drum roll, ta-da! So these are the system properties running in our container on the IBM Cloud on the IBM Container Service, which is quite cool. So we've got that. We can quickly check to see if our inventory service is working. So let me just take the node port for that. Put that there. The IP address was the URL, sorry. I'm just going to copy it in to make it easier. So inventory systems system service. So now we basically use the inventory service to get the system information, but now it should have stored that information in our list. So if we go to systems, there is our stored information, and that's the hosts we were just calling, which essentially is our other pod running in Kubernetes. So that's basically how you would get something deployed. Now, in regards to testing, there are some simple tests in here doing similar things from before. The main difference you'll notice in the test code will be the addition of, let me just show you, things like now we're getting the cluster IP and the cluster node port. Because again, we don't want to hard code these things in there. We don't know where this is actually going to go once it's deployed. So we're getting them as system properties. So an easy way to test this would be to use the Maven failsafe plugin. So I've got a command of that here. So basically all we need to do is replace, so basically this is putting environment variables into Maven. So here we're going to take our cluster IP. Easier to do this from the terminal, won't it? So we need to take this and put that in there. Then we just add in our system node port. Which is this bad boy. Okay, and finally our inventory node port. This basically will just feed to our tests where our last stuff is, so it knows what to communicate with. Okay, fingers crossed. This is going to run our tests now. It will run this against our running cluster and our microservices that we just deployed into Kubernetes. Huzzah! Yeah. Awesome. Okay, so I hope you learned something today. And basically the main thing about this is I just really wanted to show how easy this is. Once we've got to the point where we've put this in a container, we can really quite easily and simply deploy this anywhere. So again, later on in the series, we're going to take you through a few different other clouds and their Kubernetes services. And then we're going to move on to things like OpenShift and then show you some of the things that OpenShift can actually bring and make your life a bit easier with this. If you want to update this, it's very simple to do so. Again, all you would have to do is basically package your application up. So Maven package, build your system service again. So I've got a command ready to that. I'll quickly show you. The only difference here is we're going to be calling it version 2.0 because obviously we can't have it the same name. And then we basically tag it like we did before, push it up. Once it's in our container registry, it will come up as a version 2 in our images location. And then once we've done that, we can basically tell Helm using the same kind of command we had before, but rather just change Helm install to Helm upgrade. That will essentially manage our deployment for us. So we'll notice it pulling down the old image. It'll shut that container down. Then it will basically deploy the new container. But it'll deploy the new container, make sure the readiness probe's working, and then it'll shut the old image down. Sorry, I got that the wrong way around. I'll quickly show you that before we finish. Just to show you how easy it is to kind of update your deployments as a local developer. And being able to easily do this as developers allows you to do proper testing with other services from other teams, as you've seen today. So just give this a moment. Once this is done, we are going to tag it with the updated version with our namespace, etc., push it up to the IBM container registry, and then do a redeployment or an upgrade. Okay, so we're all ready. Let me just do a Docker tags. See to make sure we've got our image first. So Docker tag, we want to tag so inventory 2.0. So inventory, or should we do system? No, we'll do system. System 2.0 snapshot with basically that / system 2.0 snapshot. Okay, so we tag our new image and then we push that up to our container registry. It shouldn't take too long. Most of the layers should be there already. Really, the only two things would be the application layer. And again, updates from doing the configure sh script. So now that's all pushed up to our container registry. That's all good. I'm going to go back to here and copy in. So again, all we need to do is here is change install to upgrade. This is using system service. Yep. So expert demo was the name. Oh, and again, make sure you're in the right region. There we go. Okay, so now I can copy this in, run this, and this will then go and deploy a new version of the system application for us. So if I do kubectl get pods, we should see one container that should start to shut down. So it's, yep, see, there you go. It started up our new container, then terminated the old one. So it's great because then we don't have any of our services out of action. So that's basically it, really. The main thing I'd say is to kind of finish this off, to destroy your deployments or delete them afterwards, you can just do a Helm list. This will show you all your deployments that you have running. And then I just do Helm deletes and then say in, and then just put the name of those deployments. Tory app. See if I can spell stuff today. There we go. And then system. And then that will just go and clear up everything for me. And then if I go kubectl get pods again, we should see stuff terminating and shutting down. So yeah, I hope that kind of explained how easy it is to take any of this stack or these technologies and just show you how you can deploy them anywhere and really utilize them for cloud native Java development. One thing to note, do make sure after you finish with this that you shut down your cluster just so you're not consuming unnecessary resources. But if I do a refresh here, we should see a version 2 or snapshot 2 of our images. Yep, there we go. Oh, just the one. So this will allow you to keep track of all your different layers. And the great thing about Docker is, say, for example, we have a limit of, say, 500 meg in the container service, but because they all share the same layers, because they're using the same JVM, the same runtime, and the same dependencies of MicroProfile and Jakarta EE, we don't have to consume loads and loads of space in this this container registry. We can just consume a little bit and then just add the little layers on top of our application code or any updates to our installed packages inside our container. Okay, so I'm going to just quickly finish off with a little recap here about some of the technologies we've used today. Ooh, wrong screen. Okay. So first of all, MicroProfile. There's no vendor locking, which is absolutely amazing. Full set of cloud-ready APIs, some of which we touched on and used today, and it's got a really big community that's growing and growing. OpenLiberty is a great cloud-native runtime. It's modular, like I showed. It's really easy to configure. It's all done pretty much in one place. It's really lightweight. It scales pretty quickly. Jakarta EE certified, I think one of the first two. Also production ready. It's got loads of different and Docker images as well. Jakarta EE is a really great organization. They're part of the Eclipse Foundation, and essentially they are providing open source enterprise Java APIs. Again, the same with MicroProfile. There's no vendor lock-in, and it's a massive community that are always very welcoming. OpenJ9 is the JVM I chose to use today. It's really designed for cloud native technology, so low memory footprint, fast startup time, really high application throughput. It's got a smooth ramp up time to the cloud, and it's got loads and loads of different Docker images available. So there's some links and materials here. There's some links to MicroProfile Starter. So MicroProfile Starter basically allows you to get started creating a bare bones service. Microservice quite quickly, and there's some more information on MicroProfile on the other links. OpenLiberty also has the same thing. I haven't included the link here, but it also has an OpenLiberty starter, which essentially provides you the same thing, but just using the OpenLiberty runtime. Of course, if you want to find out more about OpenJ9, you could head to the OpenJ9 homepage, or go to the Docker downloads page. And of course, if you want to know more about Jakarta EE, head over to the Jakarta EE homepage or check out the blog. There's loads of different ways to contribute and communicate with the community. So if you are interested, do get involved. So I hope you enjoyed the first part of my series today. Like I mentioned, in 2 weeks' time, I will be back. I will be picking a different cloud, probably Azure for the next cloud. I will either be using OpenShift or the Azure Container Service. And then once we've done Azure and we've done the AWS cloud, then we'll be looking at how we can utilize OpenShift and the benefits OpenShift brings to you as a developer when you're developing these cloud native technologies. So that's it for me today. I hope everyone enjoyed this and learned something new. Any questions, do get in contact with me on Twitter or LinkedIn, and I'll do my best to answer them. Thank you, everybody.